All right, what we're going to do right now is we're going to be solving a trig equation. However, as I've mentioned in the past, when you're solving trig equations, when you're verifying trig identities, when you're simplifying a trig expression, you really need to make sure you're reading the directions. It really all looks a lot alike. So solve the trig equation, and now even within just solving trig equations, you have a lot of ways that this could be asked of you. Is this just straight up trig inverse, the trig inverse function where we'll get one answer? I don't know. Is this the type where it's between 0 and 2 pi and you give a radian answer that's on the unit circle? I don't know. Is this saying to find all solutions and you have to give a what we call general solution? I don't know. Is it in degrees or radians? You got to read the directions. Write them down in your notebook so you know why you did what you did. So my directions: solve the trig equation for all radian solutions. Running out of room. For all radian values. I don't want it to be cut off, so... for all radian solutions. All right. Now, what is the equation we are going to do? Our equation right now is cosine squared theta plus sine theta equals 1. Now, I would say that this is a challenging example to do because it requires trig identities. So we're going to have to do some subbing in with some trig identities. In particular, it'll be the Pythagorean identity, possibly some factoring and solving that way using zero product property. And then the fact that it says all radian solutions, that means we have to write our answer as a general solution, which we will go over right now. Okay, when you're solving a trig equation, first and foremost, we want there to only be one kind of trig in here, if possible. If not, we want to factor maybe by greatest common factor, grouping, AC method, difference of squares, sum and difference of cubes, whatever. But I can't factor it until it's equal to 0. With the 1 over here, if I bring that over, I can't take out a GCF. There is no greatest common factor. I can't use AC method and grouping because I have different trig. So I need to get rid of one of these two trig functions and replace it with something so that when I'm done, I only have one kind of trig here. What could I replace? Which one could I get rid of? And what could I use to replace it with something? What could I replace it with? Does anybody have any suggestions? I want to do some substitution here. I want to get rid of one of them. So when I'm done with this, I want it to either be all cosines and numbers, or I want it to be all sines and numbers. What can I do for that? Gotta try something. What do we think? Look at your Pythagorean identities. Do you have a Pythagorean identity that involves these trig functions? There's 3 Pythagorean identities. Can somebody give me the one that relates sine and cosine together? Not one person?
Is it cosine plus sine equals 1?
Well, not just cosine plus sine, but what has to change? Think about Pythagorean theorem. You're forgetting something in this. What is the Pythagorean theorem from geometry, Donovan? Used A, B, and C, right?
Yeah.
What was it?
It was, what was it? I forgot.
It was it A plus B equals C?
I think so.
Can someone help? What is he forgetting?
Sin² plus sin².
Sine squared plus cosine squared. Because Pythagorean theorem.
Oh, yeah, cosine².
Yes, thank you, Angus. Because Pythagorean theorem is a squared, Donovan, remember? Plus b squared equals c squared. So these had to be squared also, but 1 squared is just 1. So we leave that. All right, now Donovan got us to the right place. I need to use this to replace something over here. What could I replace? And there's 2 ways we can do it. If you're clever, you could kind of do a little different thing. Anyone have any suggestions? How can I use this to get rid of something here so then I won't have 2 different trigs when I'm done? You could shout out. You could raise your hand if you think you kind of know.
Can you do that over sin² plus cosine²?
Say it again. Well, I want to replace something here. I want to use substitution. So like, here's a clue. I don't want this to stay. It's squared. I have cosine squared here in the question. This is the example we're doing. But I also have cosine squared here in my Pythagorean identity. What does cosine squared theta, if I get it alone, when we used to rearrange it, when we were memorizing these, what does cosine squared theta by itself equal?
1 over secant theta squared.
Not over. You're thinking of reciprocal. I just mean to rearrange this one with addition and subtraction. Like bring this to the other side.
Sin² theta equals 1 minus cosine² theta.
Yeah, but I'm going to do it the other way where I'm going to bring that over.
So 1 minus sin² theta.
Yes. So that is what cosine squared is equal to according to the Pythagorean identity. So now I'm going to...
and then you're plugging that into the other...
Yes, and then watch what happens when we do that. When we do that, 1 minus sin² theta went in here, okay? Plus sine theta equals 1. Now, this line is a little bit better because we're not mixing 2 different things anymore. We don't have cosine and sine mixed together. Now it's just sine.
Yeah.
So we're going to be able to solve this a little bit better. What could happen with these 2 1s? Well, I have a 1 on this side, a 1 on that side. I could subtract 1, but when I did that,
0.
Right, it just cancels out exactly. So I have negative sin² theta plus sine theta equals 0. I don't like having a negative leading term, so I'm just going to divide everything by -1 just so I could have a positive leading term because I'm a little crazy when it comes to that. So I'll have sin² theta minus, see, I'm dividing a positive by a negative, minus sine theta equals 0. What do? I hope we're all paying attention and not trying to get a head start on what you're doing over there because like I said, the warm-up is what we're doing next class and it's getting us ready for a harder lesson. And I told you this is a more involved warm-up. So I hope you're really listening so you could get a lot out of this, okay? What would I do next? Remember, my goal is to solve this. What would I do to solve this a little bit further? Think of it as a quadratic polynomial from algebra 2. When you go ahead.
You bring sin² theta to the other side. Oh wait, you solving sin² theta minus sine theta.
That's the whole equation. So it's almost like if you were solving similar, like if you had m² minus m equals 0 back in algebra. You wouldn't bring m and divide by m. We never want to divide out anything that has a variable in it. My variable is not s, I, or n. The variable is theta. And I don't want to divide by theta and like eliminate it. I don't want it to reduce out entirely. I want it to stay in the problem. So what we would do here, just as a flashback, is we would take out our GCF, which is m. If I took an m out, it would go out front. That reduces to just m. Minus that reduces to 1. And then Next, I would set m equal to 0, and I would set m minus 1 equal to 0, m equals 0, m equals 1, and that's how I would do this in Algebra 2. Now, in pre-calc, we have trig involved. Go ahead.
So it would be sine theta, parentheses, sine theta, minus 1.
Yes. And if I distribute that
Equals
back,
0.
that's where that came from, but I want it factored. Equals 0. Good. And now this is where we use that property called the blah, blah property. What's the name of this blah, blah property? 0.
0 property. 0.
Product property.
Uh,
Okay. So it's the 0 product property. So I'm going to set sine of theta. I know I'm squeezing this over here. Equal to 0. And I'm going to set sine theta minus 1 equal to 0. Sine theta minus 1 equals 0. Add 1 and I get sine theta equals 1. This is where we look at our unit circle. These are all doable from our unit circle. Hopefully you're looking at it in your brain and not looking it up. If you have to look it up on a paper for now, it is what it is. The sine of what angles on the unit circle are 0. So we're going to start, even though this is finding all answers, we'll start by finding the answers between 0 and 2 pi on the unit circle. Then we'll take it a little further. So can anyone tell me what angles, theta represents an angle, will sine of that angle equal 0? And again, sine's the y value. You have the xy plane, you have the axes. The y value is 0 on the x-axis. So for which angles the sine of theta equals 0? Who can tell me at least one of those angles? At least one of them. I don't know if you're answering in the chat. I wasn't getting an alert. No, no one is. Go ahead, Charlie. What's one of those angles?
I think 0.
You're right. 0 is one of them. And anybody know what the other angle I would want is? 0 is one of them. It's the 2 spots on the side is where y is 0. Think of the whole circle. If I'm up here, sine is 1. If I'm down here, sine is -1. If I'm out here, sine is 0. So what other angle? Charlie gave us 0. What's the other angle where sine is equal to 0? The y value is equal to 0. Anybody else? Or we only got like a couple participators today? We're a bunch of zombies. Just shout it out if you know. Going once, twice. Charlie, do you know the other one?
180.
Well, we're doing everything in radians. Radian. So
2 pi or 1 pi?
pi. Pi is the other one. Now 0 and 2 pi overlap. So if I name 0, I already named that place. I don't need to name 2 pi. In fact, when the directions give you that range, they usually put a parenthesis with 2 pi and they put a bracket with 0. So you would include 0 and you would exclude 2 pi. Now, this is what we have to look forward to. If it says find all radian solutions, basically you're saying the angle could be 0. And then what we do at the end is we write plus 1 full loop around 2 pi. But then we write it with an n for both of these. Well, we'll talk about consolidating these two answers into one in the next class. But we add a full loop onto each of them. However, the n, we say n is an integer. Sorry, I'm squeezing. I'll move this up over here. N is an integer. Integers are numbers like 0, 1, 2, 3, 4, no decimals, no parts of a number, or -1, -2, -3. So this says that, yes, here 0 is an answer, but I could add a full loop on as many times as I want, as long as it's a full loop, or subtract, as long as it's a full loop. As long as I land there, anything that lands there is an answer. That's for 0. Same with 2 pi. I'm sorry, 1 pi, just pi is over here. I could add a full loop onto that. Boom, right there. Boom, boom. Or subtract any number of times I want. It's still correct. And now we have one more. We didn't do this part yet. Sine of theta equals 1. So we did sine of theta equals 0. Where on the unit circle, and then we're done with this example, where on the unit circle does the sine of theta equal 1? What angle? We're doing radians. for which angle the sine of theta equal +1. All right, Leia, what angle or angles?
Pi over 2.
At pi over 2. What is sine of theta equal at 3 pi over 2 though?
Radical 3 over 2.
Careful, don't go to 2/3. 2 over 3. 3 pi over 2.
3 pi. Oh, sorry. Sine is -1 over 2.
Just -1 on the bottom. Right? You just told me sine equals +1 at pi over 2. That's up here. And I'm asking, what did sine equal over here?
Oh, -1.
Yeah. So +1, -1, 0, and 0. So sine of theta, I was trying to white this out and I whited out 100 other things. Sine of theta is equal to 1. Leia gave us the angle. There's only one answer for this. A lot of times we get 2. When theta equals pi over 2, and we'll just do that same thing, plus 2 pi n. And as long as you write 1 time on the paper, n is an integer, that's plenty. You don't have to write it 100 times. Writing it once is good enough. So that would be the other answer over there. This yellow is corresponding to these two places right here. I don't know how this orange highlighter is about to go over the whiteout, but up here is when sine of theta is equal to 1. And I'm going to regret this, right? That's all right. It's a little too bright for you to even see. That's over there. We did a little substitution where we found that cosine of theta is equal to this. We filled that in for that in the original problem, and we just sort of solved from there. So that's what we're heading towards. We're heading towards finding all solutions where our answers are little equations. Okay, let me see if I could. Maybe that's a little better. Our answers will be like little equations, and n is an integer, basically gets us all of the answers that land in these places. But right now what we're doing, the directions you'll notice that I put for each question are going to be solve the following equation where theta is on this interval. And I only want answers between 0 and 2 pi. That means you'll have a finite or limited number of answers. Here we have infinite. You have an infinite number of answers times 3, a whole lot of infinity. If it were between 0 and 2 pi only, we would have 3 answers. Our 3 answers would be 0, pi, and pi over 2. Finished. So today you have 6 examples that we're going to work through that are all solving in radians. You're changing any directions if you printed out that packet, but you're changing any directions to just say solve using radians between 0 and 2 pi as I wrote for each of them and as I demonstrate in each of the videos. If you come back and watch this at another time and you're able to follow and understand, mark it for yourself with the thumbs up. And if you do not understand, you think this is gibberish, put a thumbs down and I will use that feedback to know what kind of examples you need more of, okay? Hope that was at least a little helpful, okay? I know it's a little confusing.